Join me as I dive into the mysteries of the universe and try to explain what really happens to a star when it dies. The life cycle of stars is a fascinating topic that has captured the imagination of astronomers and space enthusiasts alike. From their birth in giant molecular clouds to their eventual death, stars undergo a series of transformations that are both beautiful and complex. Many people think that all stars end their lives in a supernova explosion, but that's not entirely true. The truth is that not all stars die in the same way, and their final moments can be quite different depending on their mass. Some stars might end their lives quietly, while others go out with a bang. This misconception likely arises from the fact that supernovae are so bright and attention-grabbing that they overshadow other types of stellar deaths. Another common misconception is that stars are immortal. We often think of stars as eternal objects that shine forever, but they have a finite lifespan. They are born, they live, and they die, just like living organisms. The way a star dies is deeply connected to its mass, which determines its entire life cycle. So understanding the life cycle of stars is crucial to understanding how they end their lives. The diversity in stellar deaths is also influenced by the composition of the star and the presence of other celestial bodies nearby. For example, a star in a binary system might have its life affected by the gravitational pull of its companion. All these factors contribute to the rich variety of ways stars can end their lives. The life of a star begins in a giant molecular cloud, where gravity causes gas and dust to collapse into a protostar. As the protostar collapses, it heats up and eventually becomes a main sequence star, fusing hydrogen into helium in its core. This is the longest phase of a star's life, and it's where our sun is right now. But as a star ages and runs out of hydrogen, it begins to expand and cool, becoming a red giant. The fate of the star from here depends on its mass. For low-mass stars like our sun, the red giant phase is the last major event before it sheds its outer layers and leaves behind a white dwarf. This tiny hot star slowly cools over billions of years, eventually becoming a black dwarf. More massive stars, however, have a much more dramatic end. They can explode as supernovae, releasing an enormous amount of energy and leaving behind either a neutron star or a black hole. When a massive star runs out of fuel, its core collapses under gravity, causing a massive explosion known as a supernova. This explosion is so powerful that it can briefly outshine an entire galaxy, and it's often accompanied by a burst of gamma rays. What's left behind is either a neutron star, an incredibly dense object made of neutrons, or a black hole, a region of space where gravity is so strong that not even light can escape. The supernova explosion and the formation of neutron stars or black holes are among the most captivating aspects of stellar death. These remnants can go on to influence the formation of new stars and planets, showing that the death of a star is not an end, but a transformation. The elements created in the star's core are dispersed into space, enriching the interstellar medium and providing the building blocks for new stars. The death of a star might seem like a destructive process, but it's actually a crucial part of the universe's evolution. When stars die, they create new elements and scatter them throughout the galaxy. These elements can become part of new stars, planets, and even life forms. So in a way, the death of a star contributes to the birth of new stars and the creation of new worlds. Thanks for joining me on this journey through the life cycle of stars. If you have a favorite star fact or a question about stellar deaths, please leave a comment below. Don't forget to check out my other videos on space and astronomy for more cosmic adventures.